Looking at this generated model of a standard smart city, we see endless digital lights streaming upward into centralized cloud servers. Every traffic light, hospital record, and police dispatch relies on remote data centers located hundreds of miles away. If a construction crew severs a main fiber optic trunk line or a remote cloud provider suffers an outage, that constant stream of data stops. The entire municipal infrastructure instantly halts. Centralization also creates a chronic economic leak. Standard cities rely on external software as a service, or SaaS aggregators, to manage local hospitality and transit. These platforms extract a percentage fee from every local booking, constantly pulling wealth out of the town's economy. The Duricular Urban Hub Infrastructure Package is a $389,999 turnkey municipal operating system designed to sever that external dependency entirely. Delivered via multi-truck freight, this is a massive 147-node decentralized hardware stack. It is engineered specifically for dense regional townships and growing urban centers with populations between 3,000 and 10,000 residents. By running civic services on localized, air-gapped hardware, a city achieves a permanent island mode, operating securely and continuously even if the macro internet goes dark. Before a single server is shipped, Duricular engineers conduct a physical and digital site survey. They map the city's topography and measure concrete density to anticipate radio frequency interference across the grid. This structural data guides the generation of the city's unique root certificate authority. The root CA is the master cryptographic key that mints over 140 mathematically isolated identities for every piece of hardware in the incoming fleet. The foundation of this fleet is the core compute layer, the tri-redundant digital nervous system. This top-down blueprint of an urban grid illustrates the physical installation. 3 separate server racks drop into 3 distinct municipal zones, such as City Hall, Police Headquarters, and the Regional Utility Center, connected by tri-directional data lines. Each of those 3 locations houses a high-capacity Sentry Pro cluster. Together, they form a web of 9 1U server nodes, with each node equipped with 64 gigabytes of RAM. An onboard AI agent called the DevOps Sovereign manages an active-active-active redundancy protocol. This means all 3 geographical clusters process the city's network data simultaneously. If a power failure hits police headquarters, the rack goes dark. Instantly, the local network load balancing reroutes those data lines to the remaining 2 clusters. This tri-zone failover executes without dropping local data packets or interrupting critical civic services. Distributing the core compute power geographically ensures continuous operation, eliminating the single points of failure inherent in centralized server architecture. Beyond the indoor data centers, the system extends into the city streets via 100 ruggedized Nomad mesh point routers. Local utility workers mount these physical nodes directly onto light poles, water towers, and municipal rooftops across every district. They broadcast a dense, overlapping canopy of Wi-Fi 6E and LoRaWAN. LoRaWAN is a low-power, wide-area network protocol designed to connect battery-operated devices to a network over long distances. Deploying 100 hardware nodes in dense proximity introduces a severe engineering risk, network lag caused by mesh broadcast storms. In this diagram, 100 unchecked nodes attempt to communicate. They send data pings to every surrounding router simultaneously, creating continuous routing loops, a tangled, flashing web of redundant traffic that locks up the entire decentralized system. To prevent this, the deep admin core actively manages the traffic using BGP-style logic. BGP, or Border Gateway Protocol, is the mechanism that routes data across the internet by evaluating and selecting the most efficient paths between networks. The system applies localized OSFP, or Open Shortest Path First routing. The tangled web breaks apart, and the 100 nodes automatically organize into cleanly separated, self-managing subclusters with highly ordered, singular data paths. Solving the physics of mesh broadcast storms at the local level is what allows a high-speed, unkillable civic intranet to function across multiple square miles. Tapping into this municipal mesh is the professional endpoint layer, 15 sovereign Sentry desktop nodes distributed to 10 medical clinics and 5 private law offices. These nodes run heavy computational tasks locally. The medical machines process heavily isolated Postgres databases and utilize Whisper AI, a local, highly accurate speech recognition model for real-time patient dictation and document sorting. Routing highly sensitive HIPAA and attorney-client data over the exact same physical mesh hardware used for public Wi-Fi presents a massive security target. Here, we see a green medical data stream and a blue public data stream traveling through the same physical mesh router. They are kept entirely separate by virtual local area networks, or VLANs, managed by the root CA. Segmented certificates ensure that the medical packets remain completely invisible to the public Wi-Fi canopy, securely walled off inside those rotating SHA-256 encryption cylinders. But mathematical walls do not stop physical threats. Distributing ruggedized hardware across an urban grid heavily increases the risk of a physical node being stolen by organized criminals. To counter hardware theft, the system relies on the Vol-Warden defense protocol, specifically a mechanism called cryptographic suicide. If a thief breaches the physical chassis of an edge node or unplugs it from the mesh network for more than 15 minutes, the trigger activates. The hardware instantly wipes its own random access memory. It then permanently blacklists its MAC address, the unique hardware identifier assigned to its network interface, blocking the node from ever communicating with the root CA again. Uncompromising, automated hardware-level defense is necessary to establish trust when operating a decentralized municipal network. The final layer of the deployment moves from data processing to physical execution, civic hospitality, and public transit infrastructure. The package deploys 8 Sentry Pro municipal kiosks across the city, powered by a local large language model called the Sovereign Executive. These kiosks serve a dual function. They provide built-in volumetric LiDAR, using laser pulses to map 3D spaces to secure public parks. Simultaneously, the onboard AI acts as a zero-fee booking engine for local commerce and hospitality. This localized intelligence extends directly into the transit network. 15 Nomad fleet kits plug into municipal electric buses and maintenance trucks, using the CAN bus, a heavy-duty communication standard that allows vehicle microcontrollers to talk directly to each other without a central computer. An edge AI agent called the Industrial Foreman utilizes that CAN bus connection to control vehicle telemetry, managing route geofencing and autonomous dispatch. Looking at this transit map, if an event ends and a kiosk detects a sudden surge of localized data pings at the town square, it communicates directly with the Industrial Foreman. The transit network immediately reroutes autonomous shuttles to that exact zone. Coordinating 15 autonomous transit vehicles alongside core data center clusters draws significant municipal power, which risks saturating the macrogrid. The Industrial Foreman mitigates this by handshaking with local microgrid telemetry. As shown by the synchronized line chart above the charging stations, the autonomous shuttles are only cleared to pull power when local solar energy output hits peak capacity. When physical transit natively interfaces with digital mesh data and microgrid power, the city operates as an autonomous, self-balancing organism. With the complete 147-node stack deployed across the redundant core, the physical mesh, the professional endpoints, and the transit fleet, the architecture is active. This enclosed model demonstrates the result. The city grid pulses with localized, high-speed data, operating completely severed from outside network lines. If a severe storm knocks out regional fiber optics, or a global cloud provider is compromised, the local police network, medical databases, and transit fleets experience zero downtime. Economically, the local AI kiosks bypass external SaaS platforms. Every hotel reservation and restaurant booking is processed without a middleman, trapping transaction wealth entirely inside the town's borders. This is a structural rejection of the centralized smart city models of the previous decade, which digitized physical infrastructure only to outsource its control to remote servers. For mayors, municipal CIOs, and regional developers, the $389,999 package is a single perpetual investment in hardware and localized cryptography. Civic resilience is not determined by the bandwidth of a city's connection to the cloud. It is determined by the structural capability to sever that connection completely and continue to thrive in the dark.